everybody, it's Mrs. Miles, TGIF. This is your video since you missed one on Wednesday because you guys had your tests. Before we start, I want to say thank you so much for everybody who got on and did what they were supposed to do. It went so much smoother this time, and I'm so appreciative for all of you. A few of you have also reached out to me. If you missed it beforehand, we got you all situated, and so I'm just really thankful for you guys. Finally, after so long, it seems like we're all getting our bearings, and it's almost over now. So, my goodness, we're starting probability today. So sorry this took me so long, but I was digging out my cards. I was digging out my dice. This is a die from my categories game. So I think it's every letter of the alphabet, but I haven't really counted. So that would be like, 26 letters? Is that how many letters in the alphabet? Oh my goodness. And then I got my dice here, right? So you got 2 dice, you got 1 dice at a time. Certain problems talk about. I couldn't find a spinner, but you know what a spinner looks like, you know, right? So like take a peek at a book, right? You got a spinner here with four different choices. I'm hoping you guys have all played games before. So then you have like a 1 in 4 chance of getting either of those, right? So lots of different things going on with probability. I'm kind of just going to jump around. We only have 3 lessons left. This is one of them. And it should be pretty simple for you. I just want to give you a little intro into some things you might see next year because I don't know where everybody's going in different directions, okay? Not to mention, there's some of this stuff that could pop up on an SAT. So I want to make sure, I take for granted that you guys know about cards. Some of you might, and that's great, but some of you have no clue. So if you've ever known a deck of cards, you might want to write this down. A deck of cards has 52 total cards. They don't count the jokers, right? So jokers don't count. I already put those off to the side. So I have 52 cards in here. Half of them are red, half of them are black. So you got 26 red and 26 black. Okay? Then you have, see, for 10s, I don't even know, I guess I should have found the other 10s here, but you have 4 of each type. So 4 of each type. Let me see if I can get them out for you. 4 of each type. There we go. Okay, so for every card, every 2, every 3, every 4, I got the 10s right here, right? You're going to have a diamond, a heart, that's called a spade, and that's called a club. So if you ever see any of those on the SAT or anywhere and you're not sure what they're talking about, make sure you know your cards because you just never know if they'll be specific. And they might expect you to know that. Okay, so there's 4 in every suit. So there's 4 aces, there's 4 2s, there's 4 6s, and they're all different, what do they call that? Suit. So again, clubs, spades, hearts, and diamonds. Do not take me to Vegas. I am not good at this, but I do like to play a mean rummy. So if you like to play rummy, you have to come back and see me next year so we can play some of that. Maybe we can start a club, a card playing club. Okay, anywho, so I want to give you a couple of the lowdown about cards because I might talk about that later. Okay, and I'll talk more about that later, but just a little heads up, lots of fun stuff when you're working with probability. Anything can be probability. There can be a probability in which socks you pick out of your drawer every morning. There's a probability in like a bag of marbles they might talk about. They talk about all kind of stuff. So today we're going to talk about rolling 1 die. We're going to start off with that. Okay, 1 dice right here. There are 6 sides to this dice. So the probability that I'm going to roll an even number or I'm going to roll a 3 or a 5. So these are my 2 scenarios. I'm going to roll an even number or a 3 and a 5. So how many even numbers are on here? 2, 4, and 6. Out of, that's 6 total on here, right? So 2, 4, and 6, that was 3 possibilities out of 6 total sides. Think of it that way, right? 3 even numbers out of 6 sides. Okay? Or, all right, they want you to roll a 3 or a 5, right? So there's 1 3 and there's 1 5. So that's 2 out of the 6. Okay, so you add those up in this case. that means that you have 5 chances out of 6 to get one or the other, an even or a 3 or a 5. Those are pretty high chances because you're basically accounting for 2, 4, 6, 3, 5. What's the only one they left out? They left out the 1. So that's pretty good chances you're going to do one or the other, and that's why it's almost a full 100%. How do we figure out what the percent is, ladies and gentlemen? In case you're forgetting, we divide 5 divided by 6, and that is roughly 83% if you wanted to round it, right? So it's like roughly that. Okay. All right. So probability, gotta love it. Pretty easy, right? These are called mutually exclusive events because you can't have an outcome of both of these. So when that happens, all right, let's think of a different scenario. So I'm going to kind of jump around on my notes here, and I'll leave them up here. You can pause the video later to take notes when they're filled in. Mutually exclusive means these can't happen, like there can't be a common situation that hits both of these events. But let's say that you can, okay? So let's think of example 1 again. That's what I mean by this. What's the probability you're going to roll an even number? You guys told me that's still 3 over 6, right? So the probability you're going to roll an even number, you're going to add that to the probability you're going to roll a 2 or a 5. So there's a 2 and a 5. That's 2 numbers out of 6. But isn't 2 also an even number? So you have to subtract that one common, the one that you have in common. And that's what I was talking about when you see this crazy notation in your book. That is what they mean. The probability of the first event plus the probability of the second event minus what they have in common, kind of. So in this situation, that would only be 4 over 6. And if you reduce that, what is that, 2/3? Let me squeeze that in there, 2/3, right? So I know that's kind of hard to see. I'll zoom in for a minute. But that's the difference between mutually exclusive, you don't have to subtract anything. Non-mutually exclusive, you're going to have to subtract what they kind of have in common, I think of it as. Okay. Hopefully that makes sense. Let me zoom back out. Whoops, wrong way. All right, so here we go. Let's start on this one. Another die or die again, right? Probability, we're going to roll an even number. That's still 3 over 6, okay? And we're going to roll a 3 or a 5. And a 3 or a 5. So this is the key phrase here. So I write that down and I'm like, wait a minute. And 3 or 5, they want us to do this and this. That key phrase and means I need both of these to happen. Is there any way for a 3 or a 5 to be even or vice versa? Absolutely not. So I don't even have to worry about this. Is a 0 chance out of 6, which is a 0%. All right. So that is something that pops up every now and then, that the probability of doing both of these things, that key phrase and, okay, that can't happen at the same time. All right. So if it is mutually exclusive, the probability of A or B, you just add them up. But you gotta, that's an or, right? So if they have an and in there, you gotta pay attention to make sure that it can happen at the same time. Okay, and if it can't, then you're gonna have 0%. Okay, and what is the probability that you do not roll an even number? Do not roll an even. So if 3 out of the 6 are even, how many are not even? The other 3 over 6, right? So that reduces to 1/2 or 50%. Ta-da. Okay, so sweet. So that's called a complement, basically, right? So a complement is the set not included in the event. Okay, so for instance, the complement of example 1. If 83%, if that's the chance you have of doing this, the 17% is its complement. So basically the rest of the 100%. Because it's either 100% or it's 0, right? Anywhere in between. So if the complement of 0 would be 100%. So the complement of nothing happening would be, it would happen, 100%. The complement of this one, the complement of not rolling an even, which is 50%, is rolling an even, which is 50%. So that's what a complement means. That's what I have this over here for. It's basically the rest of the 100%. Okay, hopefully I'm making some sense. I'm not the best. This is why I don't teach probability and stats, because it's not my strong suit. But I'm trying here, right, because I love games. Okay, my next thing, the last thing I'm going to talk about is what happens when you replace things or you don't replace things. Okay, so this is a key vocab word, independent events. Independent events are ones that do not affect the other. Okay, they do not affect the other. So, let's think about this. Let's think about, okay, I'm going to talk about my cards. Here we are. Say I have a card and I want to pick a card, right? You pick a card, there's a probability of you picking that card. Then you put it back and you go to the next person and you say pick a card. By picking that card and putting it back, does that affect the second pick? The answer is no, right? You replaced it, and that's why I put this keyword in here. You'll see this keyword replacement. If you replace the card, you're basically just starting over again, and one pick doesn't affect the other. Okay? Now let's say I pick a 10 and I leave it out. I slide it over. How many cards do I have left here? Right? I got one less card. So that is going to affect the next one. So it's not independent. Okay? So that's what we're going to talk about in these two this last example here. These two parts. Okay, let's think. There are going to be some weird fractions too, but I want to get you used to it because you might see this. The probability of picking a red card. How many red cards did I say were in here? If you said 26 out of the 52 cards, you were right. That's probability of picking a red card. All right, with independent events, right, you are replacing it, okay? You are going to replace it now. So when you replace it, that means that you're just basically starting over, right? You're basically starting over. So, you're gonna multiply these two probabilities. But you're starting over. That means your bottom number is still 52. But you're gonna pick 10 on the second one. So how many 10s did I say you had? 4 out of 52. That's your probability of picking those. And then you're just going to multiply across the top and across the bottom to get your answer. I'm going to do my old school math that we used to do. You know, I don't know if your teacher's teaching this anymore, but I always say the 26 goes into the 52 twice. The 4 goes into the 52 13 times. Then I can multiply across the top and I can multiply across the bottom. And I have a 1 in 26 chance, or like a 3.8% chance of picking the scenario here. All right, of picking a red card first, replacing it, and then picking a 10 next. So that's a pretty small chance, but that's it. Okie dokie. So you multiply those. That's the deal with these. You're going to multiply those. All right, let's talk about this, right? So the next one, you still do the same thing with the next one. However, when you gotta pay attention, your fractions are going to change a little bit, all right? So your fractions are going to change a little bit on this one. So picking a red card first is still a 26 out of 52, okay? Times, you're going to leave the card out. Now you're going to leave the card out. So say I picked a red card, I don't know, say it was this queen, right? I'm going to leave it out here. Then I'm going to pick a spade. Oh man, how many spades are there? So, let's think of it. There is ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. There are 13 different face cards, so that means there are 13 spades. So the second time is a 13 spade, but you left that card out, so that bottom number is going to change to a 51. Okay. Now we got to multiply these together. My goodness, this is uglier. I know 13 goes into 52 4 times. 26 doesn't go into 51 anymore, but I can take a 2 out of here and a 2 out of here. So 13 times 1 is 13, and 2 times 51 is 102. That is about 12.7%. I did that in my calculator earlier. So that's a little bit of a higher chance that you're going to pick a red card and leave it out because you still have a lot of spades left in that deck because it wasn't red. So lots to think about, lots of different scenarios. Man, I could show you so many different types of stuff. I kind of just wanted to give you an intro to stuff you might have even covered in previous classes, but I wanted to refresh your memory. And I'm going to pick a few homework problems for you to try, and I wish you some luck. So have a fabulous weekend. Hopefully this isn't too painful for you. Let me zoom back out so you can see it all. Maybe pause your screen and take some good notes. And then ask me questions on Tuesdays Live if you have any, because this won't be due until next Friday. All right. Have a great weekend. Bye, guys.